If you want to learn Python data analysis and visualization, and you're also a human being, you have come to the right place. Welcome to what I think is the web's best course on Pandas and Matplotlib, Seaborn, and a whole bunch of other topics. Hey there, my name is Colt Steele. I teach programming online to over 1 million students. I won't bore you to death with the details, but this course is a special course in my opinion. It's one of my favorites I've ever made. It's a very tightly structured course that also covers a ton of material. But it's all broken down into human-sized pieces that are understandable, full of exercises. You get a chance to practice what you're learning after every single section. And we work with tons of fun, real-world data sets, including things like Amazon bestsellers, Netflix movies, Rivian stock prices, presidential tweets, Bitcoin data, and even UFO sightings. In terms of the curriculum, we start with the very basics of working with Jupyter Notebook. We get things set up and installed, of course, before moving on to Pandas Essentials. You'll learn how to read datasets in, work with data frames and series. We cover hundreds of methods. You'll learn how to organize, filter, sort, clean, aggregate, and analyze those datasets. You'll even learn how to work with dates and textual informations. You'll master hierarchical indexing and even merge multiple datasets together to form mega crazy datasets. That is the technical term. And throughout the course, you'll learn how to make visualizations with Matplotlib and eventually with Seaborn. We're talking line, bar, pie charts, histograms, scatter plots, box plots, swarm, violin, strip, point plots, and complex subplot layouts. We'll even learn how to customize the styles and appearance of our fancy plots to make more engaging visualizations. And the very best part is that you do not have to be an expert in Python. Yes, you need to know the basics of working with variables and conditionals and lists, but that's pretty much it. So whether you work in finance, data science, web dev, machine learning, or you don't work in any of those fields but you aspire to, the skills that you'll learn in this course are essential. And perhaps more importantly, I think it's just a really fun course. It's visual. It's hopefully engaging. I had a really good time making it. I'm not just saying that, I really did. And I can't say that for all of my courses. We work with these great data sets, lots of fun challenges. It's interactive, it's immediate. So I hope you enjoyed the course, and I guess that's it. Thank you. Hey everyone, welcome to this course on data analysis, data visualization, Pandas, Seaborn, Matplotlib. You probably know what the course is about because you saw the title or the promo video. By the end of this course, you are going to be a master of data and charts, and I guess you'll be able to summon them from the heavens, like this illustration shows. I couldn't decide which of these made a better course image, but this seems a bit more professional, even if this is the actual true end goal. You will have full control of the data realm. So in this video, I want to walk through the curriculum and tell you a little bit about how the course works. First, let me tell you how it does not work. This is a breakdown of how a lot of other courses, pretty much all the other courses on the platform, teach these topics. All very important topics, but all the plotting comes at the end. All the visualization it's almost like an afterthought. It's all about pandas, how pandas works, filtering, all fancy, difficult pandas operations, which is very important stuff. And then, oh, by the way, we can also make some plots at the end. So the way I wanted to structure this course is different. We're going to cover all the same topics, but I want to integrate plotting as soon as possible so that we can visualize in the exercises. We can make charts as we're learning about things like filtering or working with dates and working with text data and hierarchical indexing. I don't want to wait until the very end. So I introduce plotting very early on. We make some basic charts, don't get your hopes up too much, but we improve upon that skill set as we go. There are standalone sections on plotting with Matplotlib, more detail around plotting with pandas, and then a lot of detail with Seaborn. So I'm going to do a walkthrough in more detail of the curriculum now, which honestly is not that important. If you know you want to get started, I would just go and get started. So we begin with Jupyter Notebook, just a little introduction to installing it, using it, and then we dive right into Pandas. So we start, I'm just going to show you some of our materials. working with a couple of different data sets, reading in data sets, state populations, home sales in Seattle, real estate information, working with Netflix data as well later on in this section, doing some basic data frame operations. Pretty simple stuff, but really fundamental. We work with this Titanic data set, the passengers who are on the Titanic, and you'll learn, here's a Netflix data, you'll learn how to read in and work with that data in Pandas. And then we do some basic analysis. We talk about finding averages and mins and maxes and summing things together, finding the largest and the smallest n values, important things, but also pretty simple. Then we focus on series. So series is a different data structure in Pandas, and this is the first time that you'll see some basic plots. So nothing astoundingly beautiful or interesting, but look at that. We've got some line plots, some bar plots, some pie plots, histogram, scatter. So pretty early on, as I mentioned, we start seeing how to plot things. And then we learn more about indexing and sorting our data frames in series. And as you'll see, there's plots along the way. It's not some standalone plotting content and then we go back to Pandas. It's all tightly woven together. So then we move on to filtering, being able to filter and do some complex logic when we select rows in a data frame. So find me the homes that were sold in King County that are new constructions or were renovated after 1999 and are waterfront and have at least 5,000 square feet. Nice homes. Things like that where we can combine different criteria to select from different data sets. And here's more plotting. Then we move on to adding, removing different information from our data sets, tweaking them, updating values, replacing incomplete information. How do we handle missing data, which is a really common issue? How do we clean up data sets? And we start talking about types. How do we take textual information and turn it into floating point numbers or integers? How do we cast data? How do we handle errors? And lots of stuff around filling in holes in our data. And then we talk about working with dates and parsing dates. Really important stuff. A lot of data sets have date information. When something occurred. Something as simple as Bitcoin prices. There's a date at least in there for stocks or Bitcoin. There's all sorts of, I think the one we use, if I recall, is UFO sightings based upon the day that they occurred, the month that sightings occurred, years. We look at trends, what day of the week, what month had the most UFO sightings, what time of the night, if it was in fact at night, had the most sightings. So again, more plotting, but the whole point is that we're working with date information. And we also work with a Billboard charts data set. So you can see like Old Town Road and Lil Nas X in here. We chart the performance of songs. That's all date information. And then we focus purely on Matplotlib for a little bit. So we step away from Pandas and we just make a lot of different plots. And they start to look a little bit better. Nothing stunning, but we see how to make them from scratch. And then we return to Pandas and we take what we learned from Matplotlib to work with Pandas, and Pandas has some of its own plotting methods. It really doesn't matter if you don't even know the difference between Matplotlib and Pandas right now. That's what the course is for. But we learn how to make fancier plots with our real data sets. So we look at some salary information for public employees in San Francisco. We look at, what else? UFO sightings again. We break it down by state and by different shapes. Fireballs versus ovals and lights and flying saucers. We start to make subplot layouts where we have multiple plots side by side. So here's some more UFO sightings. And then we move on to talk about some more complicated logic in Pandas, group bys and aggregate functions. And again, we make plots throughout this entire section. We talk about a somewhat intimidating topic, hierarchical indexing or multi-indexing. So lots and lots of opportunities to practice Pandas there. We work with textual data. We'll learn how to really dive into textual information, which is also very common in data sets, and how to pull particular pieces out, how to analyze text. Then we talk about a couple methods called apply, map, and apply map. That's all I'll say about it for now. Then we cover merging different data sets. How do we combine multiple data sets together to hopefully learn more about both of them, to gain more information by creating a combo data set. And we'll visualize some things as well throughout that. And then we talk about Seaborn. So Seaborn, a really fun and very useful plotting library. We'll learn how to make not only prettier plots, but also far more complicated plots and complex layouts with multiple subplots and all sorts of different types of plots, density plots, heat maps, rug plots, violin plots, swarm plots. It's all coming up, lots and lots of stuff. And then we'll even learn how to customize Seaborn and change the plot's appearance. Not that this is a great example, but how we can, have different colors, different font sizes, different palettes, all sorts of different parameters that we can impact. So there's a lot, and I'm sure by the time you see this, there will probably even be additional sections and additional topics added in. But even if not, there's still a lot. But what I want you to focus on the most is that we integrate plotting and making visualizations as soon as possible. Even if they're pretty basic, we don't wait until the very end. It's not an afterthought. It's really part of the course and all of the exercises. So that is the curriculum. If you're still there, hello, goodbye. Next up, let's talk about prerequisites. I'll keep this short. What do you need to know to take this course, or at least to get anything out of it? There's really just one topic, and that topic is Python. You need some familiarity. You do not need to be an expert. I have a very long Python course, 30-something hours. You need the first 5 or 6 hours of a course like that. But I'm not saying my course necessarily, just in general, the first little bit of Python and programming experience. So you need to be able to work with variables, call methods with and without arguments, chain methods together, make comparisons, Boolean logic, and then work with lists and dictionaries. But most of what we do, if we just look at some of this code from any of the sections, most of it is just calling one method after another. So a pandas method and another pandas method, or here's another pandas method and some different arguments we provide, or something like this right here. This is when we learn indexing and sorting. We've got a method and another method. It's all kind of, there are times we write functions, there's times we do some things that might be a little bit more advanced, but you really, really, really do not need to be an expert in Python at all. If you've ever programmed in any language, you'll probably be just fine in this course, even if it wasn't Python. Most of what we learn is the specific APIs for Pandas, Matplotlib, and Seaborn. So even the long, more complicated plots and different code chunks here, it's really just one method call after another, after another, after another. So it's pretty easy in terms of the programming. So you do not need a lot of experience there, but you probably want some Python experience. All right, so the first thing we need to do is get set up with the tools we need for the course, and there's really just one thing we need. We're going to be using something called Jupyter Notebook. A lot of you have probably heard of it, may have installed it for other courses. It is pretty much the standard for any data science courses, any data analysis, Python courses. It's a really, really cool tool that makes our life a lot easier. So what exactly is it? It's a web-based environment for creating notebook documents. So normally Python is something we run from the terminal, or we run from a Python file, just in a text editor, for example. But when we're doing visualizations and we're working with data sets and we want to have something a bit more interactive and more visual, we can actually use Jupyter Notebook to create these notebook documents that we edit and view in our browser. They look like, for example, this. This is not your typical plain old Python file with a bunch of code. There is code in here. But then there's also output. There's images, right? We can have visualizations and charts. We can even have interactive elements with sliders and controls. There's a whole bunch of different things we can combine down into these really cool notebook documents. So there's code, most importantly, and for us, that's going to be Python. But actually, notebooks are not specific to Python. We can put CSS in them. We can put JavaScript. We can put Ruby, all different languages. Not every language, but many different languages. And then we can combine that with different text elements like headings and tables and figures and equations. We can view the output of the code. So it's really like this one-stop shop where we can have code, we can have analysis and output all together in a single document. And that's really cool, both from an education perspective and teaching you. You'll have a record of what I do. You'll see things visually, but also just for a workflow. It's a really nice workflow as you go through this course and as you continue on with data analysis. So here's the homepage for it, Project Jupyter. As I mentioned, it is not Python specific necessarily. It's used with Python a ton, but you can see a whole bunch of different languages here, right? PHP and C# and Lua and JS and all these different things. There's Python though. So it is not Python specific. But again, the idea, and here's Jupyter Notebook specifically, the idea is that we can combine code and equations, output, text, images, even audio and video if we needed, all into these notebooks that we can view and edit in the browser. So here's an example of one. I've got Python code. But this is not code, this is just text. I've got a heading and some paragraphs, and I can edit everything here. So I can do summary like that. Here's more code, and here's the output. It creates a chart, and I can edit this. So let's just change the size of this chart. I'll make it a lot taller. Not really a good change, but now we've got something a lot taller. And that's, just a simple example. Here we've got the output. We'll see this a ton. We will see this a lot in this course where we have what's known as a data frame, these columns and rows and different pieces of a data set, more charts. Here's something a bit fancier, three-dimensional visualization. I'll just show another example if I tweak something here. So I've got Python code once again. Let's change this number to 5. Who knows what that will do? Looks like some modern art. But we're getting this live 3D visualization showing up in the same document where I'm typing my code. So it's really cool, right? I don't have to go to my terminal and execute a file. I don't have to have a separate text editor. It's all in my browser. Now that's a little bit weird because Python does not run in the browser normally. So the way that this all works, without going too much into depth, is that me and you, the users, interact with our browser. So this is my browser. Here's a notebook. There's code in here. And whenever I ask it to run or I type something new, I change it. That change is transmitted to the notebook server, which I have over here. You can see this is a server running. And if you're not comfortable with a terminal, it's not a big deal for this course, but here it is. This is a server running. And that server is then interacting with the kernel, which in our case means it's executing Python code on our machine. And then whatever the result is transmitted back from the server to the browser, and we see the result displayed here. So there's a lot going on here. It's pretty complicated behind the scenes. When I make a change, let's go back to 50 here, and I run this, that change is transmitted to the server. It says, hey, Colt made this change. Can you rerun this code? Kernel goes, Python runs that code. It has a new response. That comes back from the server to the browser, and the browser shows it to me. And we finally see that result there. So it's pretty miraculous, and it makes for a really cool experience as a student and also as a teacher. I really enjoy using notebooks when I'm teaching. Okay. So that's an intro to the concept, right? We'll have a bunch of charts, a bunch of visualizations by the end. You'll have a track record of the code you run, and everything is visual. We'll learn how we can add notes and headings and figures and all that stuff as well. It's a really, really cool tool. So the next really important thing is going to be installing it. Now, some of you probably have it already if you've enrolled in other data science-y notebook using courses, but if you don't, I'm going to go through installation instructions for Windows and for Mac users. Fortunately, it's pretty straightforward. Now that we have Jupyter Notebook installed, let's talk about how we actually use notebooks. How do we make cells and manage them, move them around, work with Markdown, different shortcuts, restart the kernel, all very important things to know before we can actually dive into data analysis and Python and charting and all that fun stuff. All right? So the first most basic thing, once we have launched Jupyter Notebook, which remember we do by clicking launch from Anaconda Navigator, once that is launched, we see this page. This page will look a little different for you depending on what files and folders you have on your machine, if you're on a Mac or on a PC. But for me, I'm on a Mac right now, and it is showing me, this dashboard is showing me the contents of my user's home folder, my Colt Steele folder. This is what it looks like on Finder. I've got applications and downloads and documents and all that stuff, plus some garbage I really should delete, like orange.python and hello.js. So what I'm seeing here is just a browser representation on a web page of my file system. And if I have any notebooks that already exist, which I do, you may not, you probably don't if you're just starting this course. But if you do have one you want to open, I can navigate to it. So I know that inside of my data science folder, I've got one inside of Pandas cookbook, and here's some notebooks. So these, just to be clear, are not notebooks I actually created. These are from a GitHub repo. But what I can see is the notebook opens up, right? I see all the stuff from that notebook. So that's the step to open up a notebook. If you have Jupyter Notebook running, you have an existing notebook, click on it and it opens up. But what we're here to talk about is creating a new notebook. So to do that, all we need to do is click on New right here, Notebook, and then Python 3. If you happen to see Python 2, I mean, you can use it, but we're going to be using Python 3, so you definitely want that one. And wherever I click this, meaning whatever folder I'm currently viewing, that's where a notebook file will be created for me. So maybe I don't want one here. Maybe I'll just go back. So I have these breadcrumbs I can click on, and then I could make a new folder. I can actually make a folder from within the browser, but I kind of just prefer to do it this way, make a folder wherever I want using the terminal or using Finder. So I'll just make one called My Notebooks. Let's pretend this is where I want to work inside of this course. Totally up to you where you want to put notebooks, and you can move them around. They're just files. But I have that folder now. It just showed up automatically. And now I can make my very first notebook right here. So I clicked New, and now I have a new untitled notebook. And notice the extension .ipynb IPython Notebook. That was the old name. Before it became Jupyter Notebook, it was IPython Notebooks. So that extension is still around. It's a bit of a legacy there. So it's an untitled notebook. I can change it. I can rename any notebook just by clicking on the title. Let me show that again. Let's just call this First Notebook, and I'll rename it. Now, what am I looking at? I'm looking at a notebook that has a single cell that was created for me by default. That's what this is. Notebooks can have a whole bunch of cells, right? And those cells can be different types and do different things. So the single cell we see right here is a code cell. It was made for me. And I can type Python code in there. So, of course, we'll start with some very simple stuff like 45 divided by 7. To do that, just to be clear, to type in there, I did have to click into the cell. So clicking here does not work. This is selecting it in a different way. We'll discuss that in a separate video. I need to click into the box. All right. So if I hit enter, is it going to run? Nope. What about if I click away? When does it run my Python code? Well, it doesn't run it automatically. I need to tell the notebook to execute this cell. And there are a couple of ways of doing it. One is to click run. So if I have this cell selected, and currently it's the only cell, so it is selected, I can click run, and a couple things happen. First of all, most importantly, this code was run, and we see the output. Second of all, we see a new cell was created. So now we have two cells. Additionally, notice the numbers here. So it says in 1, out 1. This tells us that this output with the number 1 corresponds to this input cell, this code that was run with the number 1. So if I tweak this slightly, let's do 45 times 7, and I click run. Now we see in 2, because it was the next thing we ran, out 2. They correspond to one another, and the answer is 315. So that's one way of running code. Another option is to use control return. So I just ran it again. We didn't change anything, but we still see the same output. But now we see 3 and 3. So let's change it a bit. Let's also divide by 2. And then to run it, I can click run or do control return. But this is only running that cell. So if I had, other code in here like ha multiplied by 99, that's going to repeat the string ha 99 times. Well, if I come up here, let's add something. Let's do a +1. I'll execute this with control enter. This cell ran and we see the output. This one has not yet run. We can tell there's no output below it. There's no number in those square brackets, just empty. So that's the very, very basics of running a cell. we can do run like that. And we'll see, printed out, 6 and 6. And we also see it made us a new cell. That's just the behavior when you click run. If you're on the last cell, so like if I'm on this one right here and I click run, it doesn't make me a new cell below. But if I'm on the last cell, let's do something else in here, 2 plus 2, right? And I click run, it does make me a new cell below. Then there's also the option to do Control Enter right there. So let's tweak this a bit. Let's add 1, Control Enter, we'll execute it in place, and then it just shows me my result down there, 5. But it didn't make me a new cell, it didn't move my cursor. All right, so we made our first notebook, we ran some very basic Python code, but there's a lot more to learn and to understand about notebooks. I'm just going to split it up into separate videos.